In this video, we're going to talk about Gaussian elimination. So let's say that we have a matrix, let's say 1, 0. I don't know many numbers. So let's just make a few of them up. So what about we do here a -1, a -1, and a 0. And then we do a 4 and a 2 and a 2. And then we do a -1, 0, 1. All right, that's good enough. Okay, so the Gaussian elimination follows a sequence of steps. The first step is find the leftmost non-zero column. So that right there is non-zero. So that's my first non-zero column. And I'm gonna pick if there's a 1 in that column, I'm gonna call that the pivot. And I'm gonna exchange rows to put it at the very top. Fortunately, this time around, my 1 happens to be in the top position, so I don't have to do anything. I don't have to exchange rows. But later in the process, we will possibly have to do that. All right, so we have done step 1 and then step 2. Step 3 will be make zeros below that pivot position. So my pivot is 1. I already have a 0 down here. Now I'm going to make this one 0. And the way you make zeros is by doing row operations, elementary row operations. So in this case, I'm going to grab row 3 and I'm going to subtract from it row 1. And then the rest I'm going to copy the same. So 1, 2, -1, 4, -1. Do I have to say it? Sure, of course I have to say it. 0, 1, -1, 2, 0. Otherwise, you're going to fall asleep. Then it's going to be this minus this right here. So I'm going to be doing 1 minus 1. 1 minus 1 is 0. Well, that's how we rigged it, so we could have zeros below, right? That was the whole point. Now, 1 minus 2 is going to be -1. 0 minus -1 is +1. And then 2 minus 4 is going to be -2. And then 1 minus -1, remember, positive, is going to be 2. These rows look very much alike. Once you made zeros, that's actually the way I wrote this matrix. Once you've made zeros below your pivot, so you have your pivot, and there's zeros below. So now you're going to ignore that entire row. And you're going to proceed in the exact same way as we did. Find the leftmost non-zero column. Your leftmost non-zero column is this one. Same step 1 as before. So based on that one, we're going to say, do I have a 1? Yes. Is it in the top position? Yes. Okay, we don't have to do anything. If it's not, we're going to exchange rows to make that 1 the top position. And that's going to be our new pivot. So now this is my new pivot. And I'm going to eliminate zeros below that pivot. How do I do that? Well, you see, I have this one. I'm going to add +1 to make it 0. Whoop, different color. So I'm going to say row 3 plus row 2. So copy the first 2, leave those alone for the moment anyways. And then we're going to do row 3 plus. So it's going to be 1 plus -1. Well, first 0 plus 0, which is 0. Then -1 plus 1, again, another 0 there. -2 plus 2, 0 again. And 2 plus 0, I was going to say -1. 2 plus 0 is 2. All right. Now, here, we're going to now ignore these first 2 rows. And we're going to repeat the algorithm. We're going to look for the leftmost non-zero column. Well, it's just one entry. Is there a 1 there? No. Can I exchange rows to make it a 1? No. Well, then I'm going to force it to be a 1 because my pivot's got to be 1. 1/2 of row 3. And so maybe we copy the whole thing and just change that 2 for a 1. Well, I'm going to have an extra arrow, I suppose. And I'm going to paste it right here. All right, so let's now erase this one, erase this. I want to do that after. And I want to have a 1 by doing 1/2. Okay, so now this matrix is in echelon form, in reduced echelon form. No, not reduced, row echelon form. Goodness, it's just REF, reduced echelon form. And I have my pivots. My pivots are here. So to make it into reduced row echelon form, I gotta make zeros above the pivots. So this guy stay as they are, but this guy's above, this gotta go, and this gotta go. All right, so how do I do that? Well, you work your way from left to right, top to bottom. Now you're gonna start working your way backwards from right to left, bottom to top. Okay, so I'm gonna start with the bottommost pivot, or rightmost pivot, which is the same thing, and I'm going to make zeros above it. So here I'm gonna do row 1 plus row 3. So that all those zeros, you see, the beauty of this algorithm is that when you have all these zeros, they don't affect anything until you get to the one that you want to cancel. So you see, everything to the left of the pivot doesn't get messed up in the rows above, and that's what allows you to end up making zeros only above the pivots you want, and not messing the rest of your rows up. People get creative and don't follow the algorithm, and while you can get the result that you're looking for, sometimes you'll just cause trouble to yourself. So I recommend you follow the algorithm. It's not that hard. I mean, be okay with your creativity being stunted a little bit, but you would get the right answer. That was a -1. Sorry about that. Too much talking and not paying attention. All right, and then the last one remains. So now I'm just left with this one right here that I gotta eliminate. So you see, I have my pivot on the very right, and there's zeros above it and zeros quote unquote below it. That's vacuously true, but you know. Now I'm gonna move to my next pivot to the right, and I'm gonna make zeros above it. All right, so let's do that. So here I'm gonna have what I'm gonna do is I'm gonna grab the right color to begin with, and I'm gonna do row 1 minus 2 row 2. So I'm gonna make 2 minus 2 to make 0 in that entry there. So the point is to make 0 there. I should have gone in rows, so let's go in rows. 2 minus 2 is gonna be 0 as I wanted. Then -1 minus 2 times -1. So it's gonna be -1 plus 2, so it's gonna be 1. All right, now we're gonna have the next one. So 4 minus 2 times 2. So 4 minus 2 times 2 is 0. And then 0 minus 0, that's still 0. And then I have 1, -1, 2, 0, and then 0, 0, 0, 1. All right, and that is my reduced row echelon form. I have my pivots. Each one of them has zeros above and zeros below. Then I have completed the algorithm, and that's going to be the reduced row echelon form of the matrix that I started with. All right, so we're going to do one more, and we will then call it for this video. Let's start over with another one. Let's see, right there. Let's do, one more thing before. Notice that this matrix, when you go from this pivot to the one below it, there's quite a bit of or 2 columns that you skip. So that is just to illustrate that the pivots don't have to be in a column, or in a diagonal rather. They can actually move around, and that's the reduced row echelon form of the matrix is not going to change regardless of how you proceed. So you're going to always, if you get the reduced row echelon form, you're going to get the same thing. So that it just means that well, there is a theorem there that the matrices that are row equivalent actually form what is called an equivalence class, and the canonical representative would be your reduced row echelon form. So anyways, that's just to say that even if you wouldn't follow the algorithm per se, if you get the right answer is just 1. It is just one matrix that is a reduced echelon form of a specific matrix. All right, so let's do another one. Again, I don't know too many numbers, so let's do -1. Let's start with that. No 0. I started with 0 last time. So 2, 1, I don't know, 2, 1, 1, 1, 3, 2. Let's do that. It's silly. And then let's do a 1. Okay, fine, a 0 and a -1. Let's see what we get for that one. So let's get started. So now the reason why I did that is because I wanted to not have a 1 in my top position. So start with the leftmost non-zero column. That's going to be that right there. But I don't have a 1. So you have two options here, really. You could multiply times -1, or you can swap row 1 and row 2. I'm going to do row 1 and row 3. I'm going to do the swap or the exchange of rows. You could do either. I recommend that you follow the algorithm, and the algorithm would say to swap first, and then if not possible, multiply times an appropriate multiple. But again, that's one where you do get a little bit of freedom. The goal is still just making a 1 there in that position. Alright, so let's make sure that we copy it correctly, because that is the only thing that you can mess up here, well, on the arithmetic, which is a very big risk. But if you stay organized, then you'll be all right. Now, I'm going to make zeros below, so I'm going to do row 2, and I'm going to do -2 times row 1 to eliminate that. So the 2 minus 2 will give me a 0. Now, I'm going to do row 3 plus row 1 to do the -1 plus 1. So I'm going to have the 1, 0, 0 coming out. Let's copy the first row. Some people tend to, or like not to write the row that they're not affecting, only write the rows that are affecting. But to me, it becomes very difficult to track what's happening. Some people, maybe they're smarter, so they can do it. I don't. So I just write everything. So 2 minus 2 times 1, so 0. Then 1 minus 2 times 1 is -1, because 1 minus 2. 3 minus 2 times 2, which is 3 minus 4, -1. And then 0 minus 2 times this, which is +2, because it's minus negative. So the signs also sometimes get in the way, so be careful. Now I'm going to be adding. It's much easier. So -1 plus 1, 0, 2 plus 1, 3, and then 1 plus 2, 3 again, and then 3, 1 and -1, 0, so I get that. Now, so I finished that. I have 0 below this pivot. Ignore this row. Find the leftmost non-zero columns, which is that one. And then I'm going to either find a 1 or make a 1. I have already this as -1, so I'm going to just multiply times negative. This row looks a lot more convenient, because if you divide it by 3, you get 1, 1s, and then zeros everywhere else. Which that one does not look like a 0, but is a 0. Trust me, it looks more like a 6. Let's fix it. That's a 0 now. But again, just because I don't want to exchange rows and then multiply times 1/3, and I don't want to combine those two operations in one single arrow, I'm going to go ahead and just multiply the second row by -1. Again, as I said, as you get more experience, you could potentially do 2 operations at once, or 2 operations on the same row at once. I mean, because here I did 2 operations, but they were on separate rows. I still don't recommend that necessarily. But, to each his own. So 0, 3, 3, and then 0. And now now I know that this is my pivot. It's a 1. I gotta make zeros below it. So I want to do row 3, row 3 minus 3 row 2. So that right there will take care of that one. So copy the first 2 rows. And then we're going to go ahead and 0 minus 0, 3 minus 3, 3 minus 3, and then 0 minus 3 times negative 2, so 0 minus negative 6, which is 0 plus 6. So you know now that we are done with these two rows, and I look for the leftmost non-zero column, which in this case is just one entry. That's going to be my new pivot. All right, and then with that, I'm just going to do 1/6 of row 3 to make it into a 1. 1, 1, 2, negative 1. Happy numbers would Bob Ross say, right? And now I'm going to make zeros above the rightmost pivot. So I have two pivots I need to make zeros above, but I'm going to go in order. So I start from right to left, or bottom to top, but it's the same. All right. So I'm going to do row 1 plus row 3, and then row 2 plus 2, row 3. Now notice that this has zeros everywhere, so only this one will affect anything. So I'm just automatically going to get zeros for those. So let me copy that matrix. And I'm going to paste it here. Paste. Move it a little bit. Match there. There you go. And so then I'm just going to make this guy zeros above. Okay? That's just because the rest of the rows are not affected because I have zeros all the way here. So we'll skip that a little bit, just make it a little bit quicker. And now I'm gonna move to my next pivot, which is this one, and I'm gonna make 0 above that, which is going to be I'm gonna achieve that by doing row 1 minus row 2. And actually copy paste was good. In this case, I have to be careful because there's more than one non-zero entry, but I will be mindful of that. And so let's erase the two entries that will be affected. That one is going to become a 0, and then we'll calculate the next. So row 1 minus row 2. 1 minus 1, 0. That's what I wanted, 0 above the pivot. Let's make that 0 a little nicer. And then 2 minus 1, 1. And that right there is our reduced row echelon form for that matrix. All right, thank you for watching. Thank you for asking me to do this in class, because I would have not created this video otherwise. So I'll see you in the next video.